podcast. Today we're at 2, Math Class Makeover, Transformations of Polynomial Functions. The student works 1 and 2. All right, let's take a look at the next page. Getting started, applying some foundation. Consider the basic quadratic function f of x equals x squared. 3 key points are identified that demonstrate how the function grows. Use symmetry of the basic quadratic function to graph 2 other points of the function. Explain how these points demonstrate the property that f of x equals f of negative x. Okay. So if this is 1, 1, they're symmetric across this line. So if this point's 1, 1, this point would be negative 1, 1. And if this point's 2, 4, this point's going to be negative 2, 4. So the 2 other points are negative 1, 1, and negative 2, 4. The 2 other points are negative 1, 1, and negative 2, 4. These points show that f of 1 equals f of negative 1 equals 1, and that f of 2 equals f of negative 2 equals 4. Okay, go ahead and finish that up. Let's take a look at the next page. Let's consider a set of key points and the properties of symmetry to graph the basic cubic function f of x equals x cubed. Complete the table for the given key points. Then graph the points on a coordinate plane. So when x is negative 2, that's parentheses negative 2 cubed, which equals negative 8. When x is negative 1, that's negative 1 cubed, which equals negative 1. 0 cubed equals 0. 1 cubed equals 1. And 2 cubed equals 8. All right, so let's go ahead and graph our points. Negative 2, negative 8. Negative 1, negative 1. 0, 0. 1, 1, 2, 8. All right, go ahead and finish up the graph. Let's take a look at the next page. Activity 2.1, sorting transformations of polynomial functions. Linear, quadratic, and cubic functions are all examples of polynomial functions. A polynomial function is a function that can be written in the form x to the n plus x to the n minus 1 plus dot 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 x squared plus x plus a number. In a polynomial function, the coefficients represented by each number are complex numbers and exponents of variables and non-negative integers. You know that a polynomial function of degree 3 is a cubic function. Transformations performed on any polynomial function f of x to form a new function g of x can be described by the transformational function g of x equals a times f of b times x minus c plus d. Recall that constants a and d affect the outside of the function. The output values, for example, if a equals 2, then you can multiply each y-coordinate of f of x by 2. To the y-coordinates of g of x, constant b and c affect the inside of the function, the input values. For example, if b equals 2, then you can multiply each x-coordinate of f of x by 1/2 to determine the x-coordinates of g of x. Function form. When y equals a times f of x when absolute value of a is greater than 1. It's a vertical stretch of the graph by a factor of a units. When a is greater than 0 but less than 1, it's a vertical compression of the graph by a factor of a units. When a is less than 0, the reflection across the x-axis. When y equals f times b of x, b is absolute value of b is greater than 1, compressed horizontally by a factor of 1 divided by absolute value of b. When 0 is less than b, less than 1, stretched horizontally by a factor of 1 divided by absolute value of b. When b is less than 0, it's reflection across the y-axis. When y equals f of x minus c, when c is greater than 0, the horizontal shift to right c units. When c is less than 0, the horizontal shift by c units. When y equals f of x plus d, when d is greater than 0, it's a vertical shift up d units. When d is less than 0, it's a vertical shift down d units. Let's take a look at the next page. All right, go ahead and mark that off. Complete the table to show the coordinates of g of x equals a times f of b times x minus c plus d after each type of transformation performed on f of x. Vertical dilation by a factor of a. The point is x, comma a times y. A horizontal dilation by a factor of b. The point is 1 divided by b times x, comma y. A horizontal translation of c units is x plus c, comma y. A vertical translation of d units is x, comma y plus d. All four transformations a, b, c, and d. 1 divided by x plus c, comma a times y plus d. All right, let's take a look at the next page. Activity 2.2, building and sketching transformations of polynomial functions. Let's use what we know about function transformation to graph polynomials. Number 1, the graph of the function f of x equals x cubed minus 2x is shown. Describe the transformation of fx. The function f of x is symmetric about the point 0, 0. Suppose g of x equals 2 times f of x. Use the given reference points to complete the table of values for g of x. Then use properties of symmetry to graph and label g of x on the same coordinate plane as f of x. All right. When your reference point is -2, -4, the corresponding point on g of x is -2, 2 times f of -2, which is equal to 2 times -4, which is -8. When the reference point is -1, 1, the corresponding point on g of x is -1, 2 times f of -1 equals 2 times 1, which equals 2. When the reference point is 0, 0, the corresponding point on g of x is 0, 2 times f of 0 equals 2 times 0, which equals 0. When the reference point is 1, -1, the corresponding point of g of x is 1, 2 times f of 1 equals 2 times -1, which is -2. When the reference point is 2, 4, corresponding point on g of x is 2, 2 times f of 2 equals 2 times 4, which equals 8. And let's go ahead and graph this corresponding point in yellow. So -2, -8 is probably about here. Okay, -1, 2 is here. Zero, 0 is right here. 1, -2 is here. And 2, 8 is here. So your graph looks like accidentally went down. So I need to fix that. There we go. All right, go ahead and fill in the graph. Oh, almost forgot the arrows. All right, let's take a look at the next. Suppose h of x equals 1 half f of x. When the reference point is negative 2, negative 4, the corresponding point is negative 2, 1 half of f of negative 2 equals 1 half of negative 4, which equals negative 2. When the reference point is negative 1, 1, the corresponding point of h of x is negative 1, 1 half of f of negative 1, which is 1 half of 1, which is 0.5. When the reference point is 0, 0, the corresponding point on h of x is 0, 1 half f of 0 equals 1 half of 0, which equals 0. When the reference point is 1, negative 1, the corresponding point on h of x is 1, 1 half f of 1 equals 1 half of negative 1, which equals negative 0.5. When the reference point is 2, 4, the corresponding point on h of x is 2, 1 half f of f of 2 equals 1 half of 4, which equals 2. All right, let's go ahead and graph those points. So negative 2, which is right here. Negative 1, 0.5 is right here. And this is kind of getting a little confusing, so I'm going to do these points in blue so it's easier to see. All right, and then 0, 0, 1, negative 0.5, and 2, 2. Oop. I think I made a mistake. Let me double check. Negative 2, nope, we're good. Negative 1, 0.5 is good. 0, 0, 1, negative 0.5, 2, 2 is right here. Okay, so it's kind of following the same path a little bit. All right, there's your graph. All right, let's move on to the next page. The graph of the function d of x equals x cubed plus 1 half x is shown. Suppose that f of x equals d parentheses 2 times x. Use the given reference points to complete the table of the values of j of x, then use the properties of symmetry to graph and label j of x on the same coordinate plane as d of x. Okay, so when the reference point is negative 2, negative 9, that's 2 times f of negative 2, which equals 2 times negative 9, which is negative 18. When the point is negative 1, negative 1.5, this f of negative 1 equals 2 times negative 1.5, which is negative 3. Reference point is 0, 0 is 2 times f of 0, which is 2 times 0, which is 0. Point is 1 comma 1.5 is 2 comma f of 1. 2 times 1.5 is 3. Reference point is 2 comma 9. 2 times f of 2 equals 2 times 9, which equals 18. All right, so let's go ahead and graph those points, and I'm going to graph these in yellow. Now, -2, -18 is probably somewhere here. -1, -3 is here. Zero, 0 is right here. 1, 3 is right here. And 2, 18 is probably somewhere up here. All right, go ahead and finish that graph. All right, let's take a look at B. Suppose that k of x equals d of 1/2 of x. Use a reference point to complete the table of values for k of x. Then use properties of symmetry to graph and label k of x on the same coordinate plane of d of x. So when the reference point is -2 comma -9, that's 1/2 of f of -2 equals 1/2 of -9, which is -4.5. When the reference point is -1 comma -1.5, that's 1/2 times f of -1 equals 1/2 of -1.5, which is -0.75. 1/2 of 0 equals 1/2 of 0, which is 0. 1/2 of f of 1 is 1/2 of 1.5 is 0.75. When the reference point is 2 comma 9, it's 1/2 of f of 2, which is 1/2 of 9 is 4.5. All right, let's go ahead and graph this in blue. Okay. So -2, -4.5 is about right there. -1, -0.75 is about right here. 0, 0, 1.75, and 2, 4.5. All right, go ahead and finish the graph. All right, let's take a look at the next page. Complete the table to summarize the effects the transformations have on the basic cubic function c of x equals x cubed. The first row has been completed for you. The effects of the transformation on the basic cubic function f of x equals x cubed. Rigid motion. The new transformation p of x in terms of f of x. Describe the transformation. Vertical stretch dilation. When p of x equals a times f of x, when a is greater than 1, it's a vertical stretch by a units. And vertical compression dilation. When p of x equals a times f of x, when 0 is less than the absolute value of a, less than 1, it's a vertical compression by a units. Horizontal stretch or dilation. When p of x equals f times parentheses b of x is 0 less than the absolute value of b less than 1. So horizontal stretch by 1 divided by the absolute value of b units. Horizontal compression dilation. When p of x is f parentheses b of x, the absolute value is greater than 1. That's a horizontal compression by 1 divided by the absolute value of b units. Reflection. P of x equals negative f of x. That's a reflection across the x-axis. When p of x equals f of negative x, it's a reflection across the y-axis. Vertical translation. When p of x equals f of x plus c, it's up c units. When p of x equals f of x minus c, it's down c units. Horizontal translation. P of x equals f parentheses x minus c, it's right c units. When p of x equals f parentheses x plus c, it's left c units. All right, go ahead and finish it up. Let's take a look at the next page. Activity 2.3, determining multiple transformations of polynomial functions. You have graph transformations of functions in this activity. You will interpret the transformation given the graph. Analyze the graphs of f of x and g of x. For each reference point on f of x, the corresponding points after the transformations are shown on g of x. Describe the transformation performed on f of x to create g of x. Then write an equation for g of x in terms of f of x. G of x equals 3 times f of x minus 4, which equals 3 times x cubed minus 4. So when when the points for x and f of x are negative 2, negative 8, negative 1, negative 1, 0, 0, 1, 1, 2, 8, g of x corresponding is when x is negative 2, that's 3 times negative 2 cubed minus 4 equals, and to make this a little easier, I'm going to go to Desmos. I'm going to go to scientific calculator. So 3 times parentheses negative 2 cubed minus 4, 3 parentheses negative 1 cubed minus 4, 3 parentheses 0 cubed minus 4, 3 times 1 cubed minus 4, and 3 times 2 cubed minus 4. Okay, so you can see that these values correspond here. So 220, 1, negative 1, 0, negative 4, and so on. Okay, so go ahead and complete the table. And just to help you a little bit, f of x is this graph right here. And g of x is this graph right here. All right, go ahead and complete the table. The graph of f of x is vertically stretched by 3 units and vertically translated down 4 units to create g of x. All right, let's take a look at the next page. The equation of a polynomial function p of x is given. The equation for the transform function t of x in terms of p of x is also given. Describe the transformations performed on p of x to produce t of x and write an equation for t of x in terms of x. When p of x equals x, t of x equals 0.5 p of parentheses negative x. That's a vertical compressed by 0.5 units and reflected across the y-axis. When p of x equals x squared, t of x equals 2 parentheses p of x plus 3. That's vertically stretched by 2 units, translated left 3 units. When p of x equals x cubed, t of x equals negative p parentheses x minus 2 plus 4. That's reflected across the x-axis, translated to right 2 units, and translated up 4 units. All right, let's take a look at the next page. Talk to talk, just a few highlights. Given f of x equals x cubed, always, sometimes, or never to complete each statement. A. If a dilation is performed on f of x to produce g of x, then g of x will always be symmetric about the origin. B. If a reflection is performed on f of x to produce g of x, then g of x will never be symmetric across the y-axis. C. If a translation is performed on f of x to produce g of x, then g of x will never be symmetric about the origin. D. If a translation is performed on f of x to produce g of x, then g of x will never be symmetric across the y-axis. All right, let's take a look at the next page. All right, go ahead and mark this page off. Go ahead and mark this page off. All right, the student works 1A, 1B, 1C, and 1D. All right, let's take a look at the next page. The student works 2A, 2B, 2C, 1B, and 1C. All right, let's take a look at the next page. The student works 1A, 1B, 2A, 2B, 3A, and 3B. All right, go and start working on your assignment and have a wonderful Wildcat day.